5x minus 8 plus 12 over x. Now you want to do the antiderivative. Now it's much easier to do the antiderivative, right? Because now you say, well, what was the rule we learned last time? This is 5x to the 1, so add 1 to the power, divide by the new power. You get 5x squared over 2. 8 just becomes 8x. Because the derivative of 8x is 8. And 12 over x, 12 ln. Now, you have to be slightly annoying. You have to put an absolute value on the x. Plus c. Okay? So, you could have one that looked like that, for example. Let's do another type. I'll let you guys copy that down for another 2 seconds. Then start erasing. That's good. Question? Oh, well, okay. Because you can only take the natural log of a positive number. Okay? However, here when you have 12 over x, it's possible that x is a negative number. Because unless you know that the domain has been restricted, which you don't, you say, well, I'm not sure, so just to play it safe, I'll do natural log of absolute value. Other than that, I wouldn't worry too much about it. I would just say that from there, when we do the integrals, when you do something over x, you're going to need to write it as log of absolute value of x, because when you're evaluating the integral, you're going to want to make sure that what you put in as positive. So if we have it and you say find it at -4, you do the log of +4. Okay? That makes sense? So it's really just about getting the domain right. Okay. Other questions? It's a sea of people. See, there should be an aisle like up the middle here. It really wasn't well designed. Yes? Sure, you do x to the -1 now. Add 1 to -1, what do you get? So you get x to the 0 over 0. Right? So this puzzled math people for a while until they invented the natural log, essentially. Because they said that doesn't make any sense. It's actually not really mathematically true, but it's good enough. Okay? So, other questions? No. Alright? That should have spoken, it doesn't matter. Let's say that I tell you okay, let's see if you can do that. Give you 2 minutes. Okay, so our original function, our antiderivative must be, well, the antiderivative of 3x squared is 3x cubed over 3, also known as just plain old x cubed. And whenever you do something like that, always double check. Take the derivative of x cubed, you get 3x squared. That's what we want. The antiderivative of cosine x is sine x, because the derivative of sine x is cosine x, plus a constant. So far, so good. And we know that f of 0 is 8. So 8 has to equal 0 cubed plus sine of 0 plus c. Well, 0 cubed is 0. Sine of 0 is 0. 50-50 guess, right? It's either 0 or 1, and you cosine the other one, so, you know. Try to memorize those at some point. Therefore, c is 8. I have a list of all of the functions and their derivatives, functions and their antiderivatives, all the unit circle stuff, that's all up on the Instagram, okay? So if you look on there, it's there, okay? There's some other fun pictures, but if you look through, there's some math stuff in there. I promise, Chris. I swear it's there. Just keep looking, you'll find it. Okay? And I'll put this stuff up on Blackboard, and before the exam, I'll make review sheets and all that stuff for you guys, okay? And there will be a practice exam. And I will have a review session, I think. Usually the class before is a review session. Hi, Laura. You're back. Yeah. So, there you go. We're going to know all of your names before the end of the 10 weeks are up. Okay? Yeah, every one of these. Memorize. Especially. Alright, so the function is x cubed plus sine x plus 8. How'd we do? Good? Alright. Now, other stuff you can do is you can do a word problem kind of thing. Okay? For those of you who remember, have any of you taken physics in high school? You must have taken physics. Okay. You haven't taken physics in college yet, though. You have. You're brave. Alright. Generally, you want to have this course before you take freshman physics. Although physics for the life sciences is not as important. And believe it or not, physics is actually very useful for chemistry, but for some weird reason we do chemistry first. Then you'll sit in physics class later and you go, hey, I learned this in chemistry. It's really the other way around. Okay? So, but, gotta do what you gotta do. The advisors are in control. One of the things in physics is, remember, there's position, there's velocity, and there's acceleration. So position, where you are at any moment. Velocity, how fast you're moving, or in other words, what your position is changing. And acceleration, how fast your velocity is changing. So you're in the car and you're going 40 miles an hour. That's your velocity. If you step on the accelerator, you go from 40 to faster. Except not at a yellow light on this constant, because then it turns red and what happens? Camera, ticket, $85. Only once. I'm not making that mistake twice. So. I got caught at a right on red, and I was literally moving about 1 mile an hour. The wheel was kind of like, and then I went, and they got me with a camera. And I contacted the people, and I said, come on. They said, hey, did you stop? I said, well, no, $85. I said, okay, here you go. So we could do stuff with position, velocity, acceleration. And here's the fun part. The derivative of position is, so position is usually given as x of t. That's your location x at time t. The derivative of x is your velocity. Okay? So, if you have a position equation which says, if you want to find out where I am at any time, plug in this equation. And the velocity, which remember, derivative is changed throughout, the velocity tells you how fast your position is changing, so that's the first derivative. Then I want to know how fast is my velocity changing. Gas pedal. That's the second derivative, or the derivative of velocity, also known as acceleration. But of course, we could also work backwards. Okay? So, what happens is I could give you the acceleration, and now I could say, find the velocity and find the position. For example, sometimes instead of x we use a lowercase s. The book may do that. The book does do that. Doesn't really matter. You can use s, you can use x, you can use anything you want for position. Okay? Physics, they use s. But is this physics class? Yeah. Okay. So we know that the acceleration of this object is 3t plus 1. The velocity at time 0 is 6, and the position at time 0 is 24. So let's find an equation for position. So the other way is easy, because you just take derivatives. So now we do antiderivatives. So we'd say, well, to find the velocity, it's going to be the antiderivative of 3t plus 1. So that's 3t squared over 2 plus t plus a constant. So check. You take the derivative of 3t squared, and you get 3t squared over 2, and you get 3t. Take the derivative of t, you get 1. You take the derivative of the constant, and you get 0. Now we can solve for the constant. Because we know that the velocity at time 0 is 6. So when I plug in 0, I'm going to get 0 here, and you get 0 there, and you get c. So the velocity is 3t squared over 2 plus t plus 6. So far, so good? Not very hard. We can give you a harder one. We can give you, e, sine, something really annoying. It's not really necessary. I can get enough of you to get the question wrong by just using regular stuff. Because that's the goal. I'm sorry? That's the goal, right? The goal is to take doctors and destroy them. So they're not doctors anymore. Then the ones who survive, they feel good about charging lots of money. Because they go, hey, I made it. Right? That's what we're looking for, right? Okay. My goal is for every one of you to go to med school. You know that. Even those of you who don't want to go to med school. Right? Do you want to be a doctor? You do. So that's my goal. Okay. Doctor? No. Water mechanic. Hedge fund guy. Hedge fund. There you go. Alright. So now that we know velocity, let's find acceleration. So the acceleration will be the antiderivative again. So right now I have 3t squared over 2. Remember, that's really just 3/2 t squared. Okay? You don't have to do any weird quotient rule thinking for that. Okay? So, give me my eraser. So for 3t squared over 2, I'm going to have 3/2 t cubed over 3. Then t will become t squared over 2. 6 will become 6t plus a new c, which we can call c again if we want. Yes? I'm sorry? That's not a. You're right, that's position. Oh, you know what I meant. You're not old. You're supposed to say you're not old. You do want to go to med school, right? Wait, was the mic on? Alright. Okay, so now we have another round of this. We can cancel these 3's. And now we have t cubed over 2, t squared over 2, blah, blah, blah. Okay? So once again, we know that the position at 0 is 24. So these are all 0 plus c. So c is 24. So your position equation is t cubed over 2 plus t squared over 2 plus 6t plus 24. So then if you want to make it sort of a test question, you say, what's the position at time 1? Okay? And now you have to plug in 1. So you think you're done, but you have another step. Does that sound good? Okay? And if you've taken physics, you remember all those velocity equations and the initial t plus 1/2 at squared and all that stuff? You start playing around with it, this is what happens. Should I do another one of these to make sure everybody understands it? Maybe it's a good idea? Maybe it's a good idea. Sure. Well, you never know when this might show up. Generally, I do things for a reason. So if a of t is sine t plus cosine t, now we're going to find v of t. So we're going to do the antiderivative. So, the antiderivative of sine is minus cosine. Because the derivative of cosine is minus sine, so the derivative of minus cosine is positive sine. Okay. The antiderivative of cosine is sine plus a constant. So far, so good? Okay. Now, we know that v at 0 is 1, so 1 is negative cosine of 0 plus sine of 0 plus c. The cosine of 0 is also 1, because sine of 0 is 0, cosine of 0 is 1. C is 2. Okay? So some of you are going to mess that part up, because you're not going to plug in. You're just going to sort of assume things are 0 that aren't. So be careful. That's one of the places where you mess up easily on exams. Okay? Sine of 0, 0. Cosine of 0, 1. Okay. So that means now that V of t is minus cosine t plus sine t plus 2. Alright, now let's find x of t. So what's the antiderivative of minus cosine? Minus sine. Because the derivative of sine is cosine. So the derivative of minus sine, minus cosine. The antiderivative of sine is negative cosine. And if you're not sure, take the derivatives. The derivative of this is minus cosine. The derivative of cosine is minus sine. The derivative of minus cosine is plus sine. The derivative of 2t is 2 plus c. How do we do on this part? Happy so far? Okay. Now, x of 0 has to equal 2. So 2 is minus sine of 0, which is 0, minus cosine of 0, which is negative 1, plus 2 times 0, which is 0, plus c. 2 is 0 minus 1 plus 0 plus c, so c is 3. And therefore, make sure you write that last line, x of t is negative sine t minus cosine t plus 2t plus 3. Okay? How do we do on that? Is that sarcastic great or is that, no, it's actually great. Great? Great. Okay. Love your life? Love my life. Okay, good. Just checking. Alright, now we're going to actually do antiderivatives for real. So, I will warn you in advance. This is what most people consider some of the hardest stuff that we do because they have trouble with things like the notation. Okay? So we're going to now we're going to do all sorts of cool integral stuff. So we've been using the word antiderivative, but really, this is what's called integration. Integral calculus, which is what Calc B is all about. So if you go to later at a party, you can say, oh, I'm taking integral calculus. And people will be impressed when they really shouldn't be, but that's okay. We are now going to be doing area under a curve, which is 2 and 22. So 2 is actually a pretty easy problem. 22, on the other hand, some of you might find not so easy. I won't really get to that problem until Monday. Okay? Now, for those of you who have recitation before class on Monday, I'm sorry. I really am. Your TA, etc. I will tell Professor Tanase that I haven't quite gotten there yet. So she may push it back. You never know. She may also say, tough. But we'll see. Alright. Area under curve. So how would you find, well, we know how to find simple areas because we learned that in school. But suppose I wanted to find the area under something like that. From, here to there. You know, I don't know how to find that. Because it's not one of the types of area thingies I ever learned. But I know, say that's A and B, that if I took this rectangle, that the area underneath that curve is definitely more than that rectangle. No doubt. I also know that if I took this rectangle, the area under the curve is definitely less than under that rectangle, because that rectangle is bigger than the whole curve. Right? Because I got this. That stuff left over. Okay? So the area is somewhere between those two rectangles. Does that make sense? Okay. So now let's get a little better. So let's just stick with underneath for the moment. So I know the area is better than the area of that rectangle. It's bigger. But I don't know how much. So instead of one rectangle, let's make two rectangles. I kind of go like that. Well, this one is still too small. I got this stuff left over. But this one's too big. I got some extra. So it's still not the area under the curve, but I'm getting closer. So what if I did 4 rectangles? Well, now I've got these pieces which, that first rectangle underestimates, gets less than the area, but this rectangle gets more than the area, this rectangle gets more than the area, this rectangle gets a little less than the area, so I'm starting to get there. I'm getting closer. So if I add up enough rectangles, I should get a pretty good approximation. I could do 20 rectangles or 1,000 rectangles. Use a computer at that point. But I certainly could take a bunch of rectangles and find the area. Okay? So how do I come up with the areas of each of these rectangles? Well, what I do is I pick my value on the x-axis, and I go to my next value on the x-axis. So let's just change those. Let's pretend that's 1, 2, 3, 4, 5. So the width of each rectangle here is 1. From 1 to 2, from 2 to 3, 3 to 4, 4 to 5. Okay? So how do I find the height of the first rectangle? Well, the height of the first rectangle is f of 1. It's whatever you get when this curve is f of x. Whatever you get when you plug in 1. Okay? The height of the next rectangle is f of 2. Because it's what you get when you plug in 2. Okay? The height of the next rectangle is f of 3. The height of the next rectangle is f of 4. So each time to get the height, I take my x value and get up to the curve. And that gives me the height of the rectangle. Okay? And then I multiply the base times the height, and that gives me the area of the rectangle. So the area of these 4 rectangles will be the width of the first base is 1, and the height is f at 1. The width of the second one is 1, and the height is f of 2. The width of the third one is 1, f of 3, and 1, and f of 4. Okay? And then I would evaluate the function and I'd get the area. And I'd be close. Not perfect, but close. Alright, so now forget the f stuff. Let's do it with real numbers. So let's find now, LHR stands for left-hand rectangles. What do I mean by left-hand rectangles? It means to find the height of each rectangle and go to the left side of each of these little intervals, which we'll explain as we do it. Okay? Then we do it again with what are called right-hand rectangles. So you'll see. Some of you may have seen this before. Most of you said you have not taken BC calculus, so most of you have not seen this before, correct? First time. Alright. So, x squared plus 2 kind of looks like that, where this is 2, and this is the curve, f of x equals x squared plus 2, and then we go from here to there. And I'm going to do 4 rectangles. So, 2, 3, there's 4 rectangles. It's a little slanted, but it's tricky writing. I'll make that look prettier. There you go, straighter. So you don't have to look at class like this. Okay. So how do I get the width of each rectangle? Well, the width of each rectangle is just 1. It's the length from 2 to 1, from 3 to 2, from 4 to 3, and from 5 to 4. The height of the rectangle you find the following way. So I take each interval. I take the interval from 1 to 2. I go to the left side of the interval, that's 1, and I go up to the curve. So that is f at 1. and I go across. So notice, the area of that rectangle will be just less than the area under the curve. You see how it's underestimated? Because the curve is here. Okay, but the rectangle stops there. To get the second rectangle, I go from 2 to 3. So the left side of 2 to 3 is 2. Go up to the curve, get the y value, go across. That's my second rectangle. So again, it's underestimating. When I'm all done, this area is going to be less than the area under the curve. Then the next one, I take the left side, which is 3, go up to the curve. That's f of 3. And that's the area. And then for the last one, I take 4. And I go across. And I get f of 4. So what is the area? So the area is I take the width, which is 2 minus 1, times the height, f of 1. The next width is 3 minus 2. Notice those all come out 1, times f of 2. The next width, right, width times height, is 4 minus 3, f of 3. And the last one is 5 minus 4, f of 4. Okay, so each of those widths is 1, that's easy. And what is f of 1? Well, f of 1 is 1 squared plus 2, right? And the next one is 1 times f of 2, which is 2 squared plus 2. And then 1 times 3 squared plus 2, and 1 times 4 squared plus 2. That comes out 3 plus 6 plus 11 plus 18, which is 38. Okay? You check my arithmetic. We understand that so far? It's going to get harder. Although, the exam, we might give you a question that's not much more different than this. Okay? So, when I do the exam, this is usually what I test. I might give you 6 rectangles just to punish you, but that's about it. But what if I wanted to, so I'd say there's a good guess for the area under that curve, 38. So how can I make a better guess? Well, remember, each one of those rectangles is less than the area, so I know it's more than 38, right? Because I have this blank space left over. Everybody okay so far? We have some puzzled faces. No? Yeah? You guys sleeping? Checking your phones? Texting your mom? It's all good. Alright. So let's say, well, I could do right-hand rectangle. So what would a right-hand rectangle look like? Well, same equation. Now if I want to find the rectangle, the height of the rectangle, instead of using the left end of the interval, I use the right end of the interval. So I go up to 2 and go across. And notice, that area will be bigger than the area under that piece of the curve. And then from 2 to 3, I go up to 3 and across. And again, the area is bigger. I go up to 4 and across, and it's bigger. And 5 and across. So now I'm going to get more than the area under the curve. But let's do it. So the width of each of these, again, is 2 minus 1, and 3 minus 2, and 4 minus 3, and 5 minus 4. So each one of them is 1 wide. The height of the first one I find by finding f of 2, the right end of the interval. And then 1 times f of 3, 1 times f of 4, and 1 times f of 5. And what is f of 2? F of 2 is 2 squared plus 2. We found that before. And then 3 squared plus 2, and 4 squared plus 2, and 5 squared plus 2. That is 6 plus 11 plus 18 plus 27, which is, I believe, 62. Yeah. So I know the area is somewhere between 38 and 62. What's a good way to guess? Average. Yeah, why not? Sure. So what's halfway between 38 and 62? 50. Or 50. Or 50. I tend to use that one. Okay? So 50 is a good guess. And in fact, if you actually calculate the area, it's really close to 50. Okay? Can we see where I'm getting the 50 from? Take 38, you take 62, you add them together, you divide by 2. That's how you average two numbers, right? The other way you average two numbers is you ask the person next to you, what's the average of the two numbers? They tell you. But that person gets to go to med school. Alright, let's have you practice with another one like this before we do something harder. Yes? If we just ask for left-hand rectangles, then that's all you have to do. So a typical test question is, do it with left, do it with right, we do midpoints in a few minutes. You know, sometimes we say do it with 4 and then do it with 6. I mean, you can mix it up a bunch of ways, but basically we want to see if you understand the principle. Okay? Because then we're going to have you do it with an infinite number of rectangles. Just to keep you on your toes. I know. The infinite's the hard part. But I think that's question 22, 5.1. Alright? We ready? We ready to try one? Okay. We'll leave that on. Okay, this should take you guys a couple minutes. So do it twice. Do it with the 4 left-hand rectangles, do it with the 4 right-hand rectangles. That's what I thought. We'll give you 2 more minutes. This stuff is just annoying. It's the calculating that's annoying, right? Of course, how do I make it harder? I give you fractions. Right? I go from 0 to 4 using 8 rectangles. So now you have to do twice as much work, and everything has halves in it. Or you do from 0 to 1, and you have like 7. So it's like sevenths. Because it's just evil. Let's start doing this one. I could have kind of used the same picture. So 2x squared plus 3, again, you know, kind of looks like that. It's a parabola. When x is 0, you get 3, and then it kind of goes up. It doesn't really look like that. It really looks more like that, but that's not very interesting. So you scale it. Or you unscale it. Okay? And we're going from 0 to 4. So how wide is each rectangle? 1. How do we know? Well, we're going from 0 to 4. That's a distance of 4, and we're dividing by 4. So the width of each one is 4 minus 0. That's the end point, right? That's the length of the interval, divided up into 4 rectangles. Remember this when it gets more interesting. Okay? And if I want to do left-hand rectangles, the first one has a width of 1, and the height is f of 0. The next one has a width of 1, and the height is f of 1. The next has a width of 1, and the height is f of 2. And the last has a width of 1, and the height is f of 3. Okay? Make sense so far? That's the left-hand rectangle. And that should get you partial credit if you write that down. Now what is f of 0? You plug in 0, you get 3. F of 1 is 5. F of 2 is 11. And f of 3 is 21. How'd I do? You sure? Just because we agree doesn't mean we're right. We could both be wrong. We're both right. Okay. So I got 40. You guys get 40? Okay. That's my South Shore pronunciation. 40. So the South Shore, from like Massapequa. Let's H him. Alright, now let's do it with right-hand rectangles. Okay, so same picture. Okay, now the width of each of these is still 1, but the height of the first one is f of 1. The height of the second one is f of 2, because I go to the right-hand side of this interval, and I go up to there. Okay? That's f of 2. Then you get the next one, right? You go to the right-hand side, and you go up, right? So each of these rectangles is overestimated. And the last one would be f of 4. So let's see, I already found f of 1 is 5. F of 2 is 11, F of 3 is 21, and F of 4 is 35. $72. Right? You got 72? Yes! Okay. So then you could stop. Now if we said what's a good guess, you would average 40 and 72, and you get 56. So far, so good. So 56, like I said, is a pretty good guess. If you do it, it's actually like 55 and 2/3 or something. So you get very close very fast when you average the two rectangles. So what other could we do for the rectangles? Well, instead of using the left side or the right side, we could use the midpoint. So suppose I wanted to do this with midpoints. So if I had a midpoint, then instead of finding f of 0 or f of 1, well now what's happening? Well now I find that rectangle by going to the middle of each of these. So notice what happens when you go to the middle. Part of the rectangle is above the curve, and part of the rectangle is below the curve. See that? So one side is above and one side is below. By the way, these are curves that are going up. When the curves are going down, the right-hand side gives you a lower estimate, and the left-hand side gives you a higher estimate. Of course, the curve could go up and down. So one is not always bigger and one is not always smaller. So if I wanted to get the midpoints, well, these are 1/2, 3/2, 5/2, and 7/2. The width of each rectangle is still 1. The height is f of 1/2, plus 1, f of 3/2, 1, f of 5/2, and 1, f of 7/2. Remember, no calculators in MAT126. So, f of 1/2 is 7/2. F of 3/2 is 15/2. Correct me if I'm wrong. F of 5/2 is 31/2. And f of 7/2 is 55/2. I think that's right. And so you get 108 halves or 54. You just trust me on that? You can use your calculators and make sure I didn't make a mistake. And notice, that's not the same as adding the 2 and cutting it in half. Okay? It's not quite the same as halfway between the left and the right-hand rectangle. Because the midpoint, because the piece that's above and the piece that's below are not exactly the same size. So that's why it's not the same as averaging the left and the right. How do you feel about these so far? Do we love them? So how can I make it a little harder? Don't make it harder, Lois. It's hard enough. Well, I kind of have to make it harder. Because, that's my job. Remember what my job is, right? Take the pre-meds, take them as input, and the output is unemployed, unhappy, living in the street. Parents don't speak to you because you failed. Okay. I make it harder by doing things and making them infinite. But I don't know, I think that's really what I wanted to save until Monday. Well, we could start it on a little bit of that. Well, let me see, if I delay, then there's just more to do on Monday. Right? So let's do a little bit of that. Let's just work on the notation, so everybody understands the notation. Because I think that's the hard part. The infinite part is actually kind of easy. There's tricks to that. Okay. So imagine you have your curve. It doesn't really matter what the curve looks like. Okay? And you're going to start here and you're going to finish here. And you have an infinite number of these. Okay? You're not just going to have 1 or 2 or 3 of them. You're going to have a lot of them. So how would you do that? Well, first let's just do n of them. Let's not worry about an infinite number for the moment. So how wide would each of these be? Well, if there's n of them, then the width of each one is b minus a over n. Okay? So let's do this. So let's say this was from 2 to 10, and there were 6 of them. Right? Well, I'd say the distance from 10 to 2 is 10 minus 2, and I'd be dividing it by 6. Okay? So if there's n of them, I'd say the distance from a to b is b minus a, divided by n. So that's how the width of each of these is b minus a over n. So far, so good? Alright, now for the hard part. The first location is a. So the first one is going to be b minus a over n, f of a. The second one is going to have a width of b minus a over n again, and so where is this? Well, this is I went to A, and I moved b minus a over n to the right. Because that's how wide the interval is. Okay? Then the next one, the width is still b minus a over n. And I took A, and I moved b minus a over n, and another b minus a over n. Remember, b minus a over n is how wide each rectangle is. So I had 2 b minus a over n's. The next one, I have 3 b minus a over n's. So who's lost? Lots of you. I'd be lost. Okay, so again, the width of each rectangle is the distance b minus a, that's the whole length, divided by n because there's n rectangles. Okay? So if I had 100 rectangles, I would take however far it is from b minus a and divide it by 100. Then the first spot on the left is a. Then to get to the next spot, I move 1, rectangle width. And the width is b minus a over n. Okay? Then the next one, I move from there another b minus a over n to the right. So I move 2 b minus a over n. And to get to the next one, I move 3 b minus a over n's. And I keep doing that, dot, 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 until I get to the last one. Okay, so how many of these do I do? Do I do n of these? Not quite. There's a total of n, but I started from 0 of these. So I'm going to finish at n minus 1 b minus a over n. Why n minus 1? Well, say I had 100 of these. Okay, I would go from 0 to 99. That makes 100 rectangles. I'm starting on the left side. So first I would add nothing. And I'd add 1 width, I'd add 2 widths, right? I'd add 0 widths, 1 width, 2 widths, up to, if there was 100, up to 99. Because then I've had 100 of these. So if I went up to n, if I had n of these, I would go up to n minus 1. Does that make sense? Okay, so that's one form of the notation. Now, that notation is really not pretty. So we can make that a little more compact. Instead of calling this b minus a over n, yes, this is left hand. All left hand. Okay? How do I change this to right hand? Right hand, I start with the second one, and instead of finishing at n minus 1 times b minus a over n, I finish at n times b minus a over n, which would be f of b. Okay? So, how do I make this more mathy and therefore more compact? Because that's what mathematicians do. Okay? No more A, B stuff. I start at x sub 0, I finish at x sub n. Okay? And I call the width of each of these rectangles delta x. Love that delta. So the height of the width of each of these is delta x. The height of the first one is f of x 0. The height of the width of the second one is delta x. And then f at x1 is delta x, f at x2, and I keep going until I get f of x minus delta x. F sub x sub n minus 1. Does that notation make sense to people? Look at that, make sure you can process that. So each one of these is the width of delta x, whatever delta x is. How do you find delta x? Delta x is b minus a over n. Told you, this is the most theoretical part of the course. The most abstract is what we're doing these couple of classes. Then it gets kind of less abstract and more concrete. I certainly hope so. Okay? So b minus a are just the endpoints of what you're doing in your area from a to b. N is how many rectangles you want. And delta x is just b minus a divided by n. Okay? And in the height of these, well, if you're doing left-hand rectangles, you start at x sub 0 and you finish at the next to last one. Because the next to last one starts at x sub n minus 1 and finishes at x sub n. If I wanted to do right-hand rectangles, I would start at x sub 1, and I would finish at x sub n. Yes? And that's the next step. You beat me. Okay? I'll say that out loud for everybody in a second. So, another thing I could do is I could factor out delta x. So, left-hand rectangles is delta x times f of x sub 0 plus f of x sub 1 plus f of x sub 2 plus dot 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 plus f of x sub n minus 1. And the right-hand rectangles is delta x f of x sub 1 f of x2, f of x sub 3, f of x sub n. So far, so good? It's all good to end the video. And by the way, I don't yet know exactly where the videos will be, but we upload them, and then Professor Tanase will create a place on the web page. You may already have done that. Not yet. And it'll be something that'll say something like videos. Okay? You'll click on that, and then the videos will be connected to the course. She just has to get around to doing something called a PHP script. Any of you computer science majors know what the heck that is? You do? Dude, you want to do it for us? Yeah, I have no idea, but apparently she's really good at this stuff. I mean, her webpage looks like this. Mine looks like crayons and like a kidnapper's ransom note. Okay? Now, one more thing we could do to really make this compact. Ready? Sigma x, or n, I equals 0, n minus 1 of f of x sub I. You guys all know what the sigma means. The sigma literally means do this. Okay? Sigma stands for sum, and it means start at the bottom number, plug it in for I, keep going, keep incrementing this by 1, stop when you get to n minus 1, and add them all up. So, plug in 0, plug in 1, plug in 2, till you get to x sub n minus 1. If you wanted to do with right-hand rectangles, it would be sigma I equals 1 to n of f of x sub I. Okay? So you see the difference? This one goes from 0 to n minus 1. This one goes from 1 to n. And it says literally you just plug in for I and add them up. So these two are exactly the same. Sigma is just an even smaller, more compact and mathy way of writing this. Do this at parties. It really impresses the ladies. Yes? It actually does. Yes? That's an I. So this says I equals 0 to n f of x sub I. Kind of hard to write down here. I should have a child just sit down and write for me. You wouldn't notice the handwriting difference. I know, it's not really that bad, but... Okay? I think you've all had enough for one day. Question? Because I'm starting at 0 and I'm finishing at n minus 1.